The payments industry moves fast. The economics behind it move even faster. Welcome to On the Wire, a show about the economics of payments, the institutions moving money, and the infrastructure underneath it all. This episode is produced by payware using AI voice synthesis, built from primary research, technical documentation, and real market data. No studio, no hosts, just the content, clearly presented. Let's get into it.
Right now, your bank's most profitable transaction might actually be the one where the money never, leaves your building.
Yeah, which is kind of ironic when you think about it.
Right. But to unlock that transaction, you have to connect your internal systems to a massive global network. And, well, that is exactly where the panic usually sets in.
Oh, total panic. I mean, if you sit in on a product meeting at pretty much any mid-sized bank today, the mandate from the top is incredibly clear.
It's all about account-to-account payments, right? A2A.
A2A. Customers want to pay merchants directly from their bank apps at checkout. And, competitors are heavily marketing it.
So everyone feels the pressure. But the real fear in that room isn't really about whether A2A is a good idea for business.
No, the business case is solid. The real fear is entirely architectural.
Yeah, it's the sheer terror of touching those legacy core banking systems. I mean, some of these mainframes have literally been running since the 1980s.
Yep, written in COBOL, batch processing overnight.
And now you're asking them to enable real-time, 24/7 API callbacks.
It is the ultimate bottleneck in modern finance. The commercial why is obvious to everyone, but the technical how just, it paralyzes their roadmaps.
Totally.
Product teams look at the sheer scale of integrating into a major interoperability network, and they just assume it's going to require, a dedicated engineering task force.
Like a massive budget.
Yeah, and years of beta testing to make absolutely sure they don't accidentally expose their internal ledger to some crazy security flaw.
Well, we have a source document today that essentially serves as a roadmap out of that exact paralysis.
It's a great read, honestly.
It is. It's titled Integration 101, How Payment Institutions Connect to Payware. And our mission for this deep dive is to basically tear down those assumptions about what an integration actually requires today.
Because it's changed a lot.
It really has. We're going to look at the technical blueprints, the hard financial costs, and the strategic deployment of connecting a payment institution to a neutral A2A network.
So where do we start?
Okay, let's unpack this. Because before we get into the weeds with API endpoints and synchronous callbacks, we really need to look at how this network fundamentally operates at a high level.
Yeah, the architecture is key here.
Right. Payware uses a very specific division of labor to make this work at scale, doesn't it?
It does. The architecture of the payware ecosystem relies on 3 distinct pillars. And keeping them entirely separate is, well, it's what bypasses the usual go-to-market nightmare.
Okay, break those pillars down for us.
Sure. First, you have the payment institutions, so the banks or the PSPs. Their only responsibility in this ecosystem is managing the consumer side, the payers.
Just the people spending the money.
Exactly. Second, you have the merchants who are actually receiving the funds. And then sitting right between them is payware.
Acting as the bridge.
Right, functioning strictly as a neutral interoperability layer.
And that's a huge shift. Because historically, if a bank wanted to roll out a new payment rail, they had to play both sides of the field.
Oh, it was a nightmare.
They had to build the tech for the consumer app. And then, this is the crazy part, send a massive sales team out to convince merchants, one by one, to put a new physical terminal on their counter.
Which is your classic chicken and egg problem. It usually ends in failure because, neither side wants to adopt a network that the other side isn't using yet.
Why would a merchant install a terminal if no customers have the app, right?
Exactly. But in this model, payware abstracts away the entire merchant side for the bank.
That is massive.
It is. When a bank integrates its app with the payware network, their customers can instantly check out at thousands of merchants on day one. 0 merchant onboarding required by the bank.
It's exactly like global cellular roaming.
Oh, that's a good way to look at it.
Yeah, think about it. As a consumer, you don't sign a new contract with a local telecom company in every single country you visit.
No, that would be ridiculous.
Right, you just connect to your home network, and your provider uses a neutral routing layer to give you service everywhere. Payware is essentially acting as that roaming layer, but for retail checkout.
If we connect this to the bigger picture, that roaming analogy highlights the structural genius of the network perfectly. But There is a secondary effect to this architecture that fundamentally changes the bank's unit economics.
The on-us transaction.
Exactly. Because payware acts as this massive neutral aggregator for merchant accounts all over the place, a mid-sized bank suddenly finds that a significant percentage of its outbound A2A volume is actually landing in merchant accounts held at their very own bank.
Wow, so payware is essentially manufacturing on-us transactions at scale.
Yes, and for anyone managing a bank's P&L, an on-us transaction is basically the holy grail.
Because the money never actually leaves the building.
Right. It doesn't have to route through external clearing systems like SEPA or SWIFT.
Which cost money and take time.
Exactly. The bank just updates its internal ledger, they debit the consumer, and they credit the merchant.
And what does that ledger update actually cost the bank?
Essentially zero.
Zero.
Yeah. So by plugging into this roaming layer, the bank isn't just, checking a box for a new product feature to keep marketing happy. They are suddenly capturing a tier of high-volume, everyday transactions where their profit margin is just exceptionally high.
So the business case really writes itself here. You have zero-cost ledger transfers. You get immediate access to a massive merchant network. A product team looks at this and says, great, let's start building.
You'd think so, yeah.
But the blueprint in the source document dictates that the first 4 weeks of this integration, what they call phase 1, involves zero coding.
None at all.
Which feels counterintuitive. Why does a purely technical API integration require a full month of talking before anyone even touches a server?
Well, because a flawless API handshake doesn't matter at all if your risk framework is broken.
Compliance.
Always compliance. Phase 1 is all about commercial alignment and mapping out liability. Before you commit any engineering resources, you really have to size the opportunity.
And the source document actually models this out, right? With a highly realistic scenario.
Yeah, they use the example of a regional bank with 2 million account holders.
But they don't assume all 2 million will use it. They filter that down pretty aggressively.
Very aggressively. They isolate about 400,000 users who are prime candidates. So, people with high mobile banking engagement, frequent retail shoppers, that sort of profile.
Okay, and then they apply a very conservative adoption rate. I think it was 10% for the first year.
Right, 10%, leaving them with 40,000 active API users.
Which doesn't sound like a massive number out of 2 million.
It doesn't, but now look at the volume projection. If those 40,000 users execute just 3 A2A payments a month at an average basket size of, say, 45.
You are suddenly looking at 65 million in annualized volume.
Exactly. That rigorous mathematical baseline is what actually justifies pulling developers off of other critical projects.
But the source also notes that the math only dictates the size of the opportunity. The bank also has to determine the nature of their strategy.
Right, the commercial positioning.
Are they playing offense or defense?
Which is a fascinating question for a bank to ask itself. Are they launching this feature to aggressively acquire a younger, tech-forward demographic away from competing institutions?
Like trying to steal market share.
Yeah. If so, they need a high-visibility marketing campaign. They're playing offense.
But what if they are noticing severe deposit leakage? Like their current customers are transferring funds out of the bank just to use third-party fintech wallets.
Apple Pay, PayPal, whatever. If the goal is to stop that leakage and keep those users entirely within their own app environment, that is a defensive posture.
And does that change the actual coding part?
Not at all. The technical build is identical, but the rollout strategy, how you present it to the user, is completely different.
That makes sense. And while the product team is busy arguing about offense versus defense, the legal team is spending weeks 3 and 4 navigating the compliance reality of neutral interoperability.
Oh yeah, and the regulatory scrutiny here is intense.
Because of that neutral layer we talked about.
Exactly. Because payware is a neutral layer, it never actually authenticates the customer. Think about it.
Right, it's the bank's app that handles the biometric login, the Face ID or the fingerprint.
Precisely. And under PSD2 regulations in Europe, that means the bank holds the liability for strong customer authentication, or SCA.
Wait, so if a fraudster steals someone's phone and somehow bypasses the biometrics, the bank has to own that failure, not payware.
100%. The bank.
Yeah.
Payware just routes the message. The bank said this person is who they say they are, so the bank holds the bag.
Wow, okay. That really explains the massive compliance checklist in the document.
Yeah, they don't mess around. The bank has to prove its anti-money laundering systems, its know your customer protocols, and its real-time transaction monitoring can actually handle this new flow of data.
Plus, they have to sign off on specific data sharing agreements just to remain GDPR compliant. The legal architecture is honestly just as complex as the technical one.
It is. And only when that liability is clearly mapped out and the ink is completely dry on those agreements does the bank actually receive the cryptographic keys to enter the developer sandbox.
Which brings us right into phase 2, the engine room, weeks 4 through 8.
Time to build.
The legal hurdles are cleared, and we need to establish the payment handshake. Let's dissect the mechanics of the core use case here. The QR code scan-to-pay flow. How does the bank's back-end system actually talk to the merchant's physical terminal?
Let's trace the data payload step by step.
Okay, lay it out.
So a customer points their bank app at a merchant's QR code. The app decodes a transaction ID string that's embedded right in that QR.
Got it.
The bank's backend then fires a synchronous query to payware's API, essentially asking, hey, provide the details for this specific ID.
And this happens instantly.
In milliseconds.
Hmm?
Payware returns a JSON payload containing the merchant's name, the exact settlement amount, and the transaction reference.
Okay, so then the bank's app processes that JSON payload and renders a localized screen for the user. It says something like, pay 4.50 to Main Street Coffee.
Exactly. The user sees that, they authenticate with their fingerprint or Face ID.
The bank authorizes the internal debit on their side.
Right, and then the bank fires a confirmation message back to Payware's endpoint stating, yes, the funds are secured.
Seems pretty straightforward so far.
It is, for the synchronous part. But the real complexity lies in what happens next. The asynchronous updates.
Right. The document heavily emphasizes this requirement for status callbacks.
Yes. The bank must expose a public-facing HTTPS endpoint. It's essentially a secure webhook receiver.
Why do they need that?
Because as the transaction moves through its final life cycle on the merchant's end, like the cash register actually printing the receipt, Payware fires automated status updates back to this webhook.
Ah, so the bank has to ingest that incoming message from the web.
Instantly, they have to verify the cryptographic signature to ensure it wasn't spoofed by a bad actor. They have to check an idempotency key to make sure they haven't already processed this exact same message milliseconds ago.
And then update their core ledger, all in real time.
Exactly. And then, of course, they have to manage the actual movement of funds later.
Because the messaging happens in milliseconds, but the actual money moves differently.
Right. The settlement usually occurs via SEPA Instant. Payware collects its 0.5% fee on the volume, and the bank has to integrate with a completely separate settlement API to pull daily reconciliation reports.
Matching the net settlement amounts perfectly against their internal accounting, down to the cent.
Every single day.
Okay, hold on. I need to jump in here and really challenge the reality of this timeline.
Okay, go for it.
The source document clearly states this phase requires 4 to 7 person-months of effort.
That's what it says, yeah.
We're talking a tech lead, back-end engineers, QA specialists, all dedicated for months. I talk to product teams at mid-sized banks all the time. Their IT backlogs are literally years deep. They are dealing with those legacy core banking systems that batch process ledger updates overnight.
The COBOL dinosaurs.
Yes. They're not natively built to ingest high-volume, real-time webhook callbacks.
No, they're really not.
So if Payware requires half a year of dedicated engineering just to build the middleware to translate those real-time APIs for a legacy core, I mean, this blueprint is dead on arrival for 80% of the market. They simply don't have the developer bandwidth. Did they just miss the boat?
That is a very fair critique, and what's fascinating here is the architects behind Payware are acutely aware of this exact legacy core dilemma.
They know the banks are struggling.
Oh, they know. They know that asking a mid-sized bank to build real-time middleware from scratch is a total non-starter, so they engineered 2 distinct accelerators to bypass the IT bottleneck entirely.
Okay, what's the first one?
The first is straightforward, capital deployment. You just throw money at the problem.
Ah, the managed integration service.
Exactly. For an additional upfront cost of, say, 15,000 to 30,000 euro, Payware deploys its own specialized engineering unit.
They do it for you?
Pretty much. They act as an extension of the bank's IT department. They write the custom middleware needed to bridge Payware's modern APIs with the bank's older SOP interfaces or, batch processing logic.
So it trades budget for time.
Exactly.
But here's where it gets really interesting to me. Because if a bank doesn't want to outsource the architecture, they can use the second accelerator, which the source calls the MCP server.
Yes, the MCP.
This completely changes the resource calculation. How does MCP actually function in this context?
So MCP stands for Model Context Protocol, And it essentially bridges the gap between raw API documentation and executable code.
Okay, unpack that a bit.
Well, traditionally, a developer sits down, reads pages of API docs, figures out the required authentication headers, manually types out all the JSON schemas.
It's tedious.
Yes, extremely. And then they have to write the logic to handle network timeouts and retries. It takes weeks of trial and error.
But with MCP, they are feeding a machine-readable definition of payware's entire API directly into an AI assistant, right?
Yes, exactly. The AI already understands the exact cryptographic requirements, the specific endpoint structures, the required data formats.
So the developer just asks the AI for the code.
Pretty much. An engineer can prompt the AI, and it will instantly generate the foundational middleware. So the webhook receivers, the signature validation logic, the idempotency checks.
And it writes it in the bank's native programming language.
Yep. Java, Python, C#, whatever they need.
That is wild. The AI is essentially writing the boilerplate translation layer for them.
It is. The engineers transform from manual typists into code editors. They just review the generated architecture, ensure it meets their internal security standards, and then they can focus solely on the custom logic of connecting that modern layer to their specific legacy mainframe.
It skips all the grunt work.
Exactly. And the source data confirms the impact of this approach.
Yeah.
By utilizing MCP for AI-assisted code generation, banks are shrinking the total technical timeline down to an absolute minimum of 5 to 6 weeks.
Well, down from 4 to 7 person months?
Right. It completely neutralizes the excuse that a bank doesn't have the developer bandwidth.
Wow. Okay, so the business math checks out, the compliance liability is mapped, and the AI has drastically accelerated the API integration.
We're making good time.
We are. But, in the banking sector, a successful ping in a Sandbox environment doesn't mean you were ready to flip the switch for millions of real consumers.
Oh, definitely not.
Which brings us to phase 3, operational readiness. This is weeks 9 through 12.
And the Sandbox testing leading up to this phase is just brutal by design.
Because they can't afford for it to fail in the wild.
Right. They aren't just testing the happy path where, a customer scans a code and the network is fast and everything works perfectly.
They're deliberately injecting chaos.
Lots of it.
This is edge case testing, right?
Precisely. They ask questions like, what happens if the SEPA instant network goes down 3 seconds after the biometric authentication?
Oh, that's a nightmare scenario. The money's gone but not settled.
Exactly. How does the bank's app handle a suspended transaction state? Or what happens if the user scans the code but gets a phone call and doesn't actually authenticate for 15 minutes? Does it time out safely?
Good question.
They simulate 500 transactions per hour just to monitor latency. They deliberately attempt to bypass authentication headers to test the security boundaries.
And once the system survives that gauntlet, phase 3 pivots entirely to the human element of operations, doesn't it?
Yeah, the tech works, now the humans have to manage it. Customer support teams need incredibly detailed playbooks.
Right, because if a payment fails mid-flight, a support agent needs a troubleshooting dashboard to tell the customer exactly why it failed. Sorry, your network timed out or whatever.
Exactly. And IT operations must set up sophisticated monitoring tools, latency alerts, error rate spikes, API health tracking. The system has to be maintainable, not just functional for day one.
Which naturally brings the entire discussion down to the hard budget.
The bottom line.
Right. The source lays out the actual capital expenditure required to execute this entire blueprint. Let's look at the one-time upfront costs first.
Okay.
Factoring in the payware integration fee, the internal staff time diverted to development, and that rigorous QA testing we just talked about.
Okay.
The total runs between $30,000 and $70,000.
Which is, for a mid-sized financial institution, spending under $100,000 to deploy a nationwide, real-time consumer payment capability.
It's nothing.
It is an astonishingly low capital expenditure.
And the ongoing operational costs are equally predictable, right?
Yeah, you have the 0.5% volume fee to payware, and then roughly $12,000 to $25,000 annually in internal staff time for maintaining those monitoring dashboards and routine API maintenance.
It's highly measurable.
Yeah.
And to prove this isn't just, theoretical modeling in a spreadsheet, the source provides a granular case study of a real-world regional German bank that executed this exact playbook.
They are the perfect proxy for the broader market, too.
They really are. They had 1.5 million total account holders, a very lean 5-person back-end engineering team, and just a standard mobile banking app.
And they followed the timeline strictly. 2 weeks of commercial and legal alignment, 4 weeks of API integration. And remember, their 2 back-end engineers only dedicated about 70% of their time to the build.
So they were still doing their day jobs.
Exactly. Then 3 weeks of intense sandbox testing, where they cleared over 150 edge cases. And by week 12, they were live in production.
The deployment speed is impressive, for sure. But the metrics 6 months post-launch are what really dictate the success of the strategy here.
The results speak for themselves.
They do. After 6 months, they achieved 45,000 active A2A users.
Which tracks with the early model.
Right. And those users were averaging nearly 3 transactions a month, which generated $28 million in annualized transaction volume.
That's real money moving through the system.
Plus, they reported a 4.6 out of 5 customer satisfaction score, proving the UX wasn't clunky.
But the metric that validates the entire architectural model, the one that fundamentally alters the P&L, is the on-us capture rate.
Right, tying back to our roaming analogy from the beginning.
Because payware already commanded such a massive footprint of merchants across Europe, 12% of the bank's total outbound A2A volume was naturally routing to merchants who banked with that very same institution.
12% of 28 million in volume never hit an external clearing network.
Exactly.
The bank literally just updated its internal ledger. They unlocked a massive tier of near zero-cost processing, translating into pure margin instantly.
It's a huge win for them.
So what does this all mean for you, the listener?
It's a paradigm shift.
It really is. The narrative in the banking sector has been stagnant for years on this topic. The prevailing assumption has always been that building real-time interoperability is just too expensive, the legacy tech debt is too deep, and the engineering bandwidth simply doesn't exist.
But this source material completely dismantles that assumption.
Through a combination of neutral interoperability networks, standardized webhooks, and crucially AI-accelerated code generation, the technical barriers have effectively been stripped away.
The bottleneck is no longer about feasibility.
Right. It is entirely about strategic timing now.
And that is the critical takeaway. The technology is essentially commoditized and solved. The risk profile has completely flipped.
How do you mean?
The highest risk is no longer the complexity of the build. The highest risk is the cost of waiting.
Exactly. Whether you are preparing to lead a product strategy meeting tomorrow, or you are simply tracking the evolution of modern financial infrastructure, the reality is that the blueprint is tested and it's available.
It's out there.
Every single month, a payment institution delays their A2A rollout. They're actively allowing their competitors to train their customer base to use an alternate interface.
Which is dangerous.
Very. The window to play offense and capture market share is narrowing. Very soon, the entire market will be forced into a defensive posture, just to stop deposit leakage.
This raises an important question, actually, and I want to leave you with a final thought based on a very deliberate piece of phrasing in the source text.
Oh, I know the quote you're thinking of.
Yeah. The document explicitly states that payware never holds funds, never authenticates customers, and never competes with the institutions that depend on it.
Which is rare in fintech.
Very rare. So as you watch the broader technology landscape where massive Silicon Valley tech giants are systematically trying to monopolize the entire consumer relationship from discovery to final settlement, consider the strategic value of neutrality.
That's a great point.
How long until a strictly neutral infrastructure, one that explicitly refuses to compete with its own banking partners, becomes a traditional financial institution's most powerful competitive weapon against big tech encroachment?
That is a phenomenal question to end on, because the true source of panic in that glass-walled conference room shouldn't be the API documentation or the legacy mainframes.
That and more?
It should be the realization of what happens to the institution if you choose not to integrate it all. Keep questioning the hidden mechanisms of the financial tech around you. Keep looking for those high-margin architectural advantages, and we will catch you on the next deep dive.
That's On the Wire, produced by Payware, the transaction resolution network for instant A2A payments. This episode was AI-generated from Payware's published research and documentation. If something sparked a question, the full source material is available at payware.eu. If you work in payments at a bank, an ISV, or a merchant organization, and what you heard is relevant to what you're building, reach out. The conversation doesn't have to stop here. Subscribe to On the Wire wherever you listen to podcasts. The next episode is already waiting.